So we look at volume of prisms. Now what is a prism? Well, a prism is a three-dimensional shape whose cross-section is consistent throughout the length. So basically a prism is a three-dimensional shape which is uniform. And volume, what's volume? Well, volume is the inside of a three-dimensional shape. So if you had a can of Coke, the volume would be how much Coke you could fit inside that can. So how do we calculate volume? Well, the formula for volume is volume equals area of cross-section multiplied by height, depth, length, whatever you want to call it. It depends on which way the shape is. So what is the cross-section? Well, if I draw a rough cuboid, the area of a cross-section is the area of this front face here. And as is a cuboid, that's going to be a rectangle. And what's the height? Well, the height is just how far it's been stretched back. So if I draw a triangular prism, what's a cross-section? Well, a cross-section is this front face here, and the height is, again, how far it's been stretched back by. So now that we know what the cross-section is and what to take as our height, let's look at a few examples of how to calculate it. If we're calculating the volume of this cuboid, well, I'm going to have to work out, first of all, the area of the cross-section. And to work out the area of that cross-section, well, it's a rectangle, and the area of a rectangle is base times height. So that's going to be 4 times 2. And then I need to multiply that by, the stretch, the length, the height, whatever you want to call it, which is 5 centimetres. So it's 4 times 2 times 5, which is, of course, 40. Now, because volume is of a three-dimensional shape, we've got to multiply centimetres by centimetres by centimetres, which gives us centimetres cubed. Let's look at another example then. Try and calculate the volume of this triangular prism. Well, I need to work out the area of a cross-section, being this triangle. And to work out the area of a triangle, well, it's half of a rectangle or square, so it's half base times height. So it's 1/2 of 10 times 5, which gives me the area of a cross-section, times by the stretch, which is 10, which gives me a half of 50, which is 25. So it's 25 times 10, which is 250. Now it's meters times meters times meters, so it's meters cubed. Let's look at one final example then. Let's work out the volume of this cylinder. Well, the volume is the area of a cross-section, which in this case is a circle. So I'm going to work that out by using the formula pi r squared, where pi is 3.14, r is radius, which is 10, so it's times 10 squared. So that's the area of a cross-section, and then I'm going to multiply that by the stretch, which is 100. Now that's 3.14 times 100 times 100, which is 314 times 100, which is 31400, or 31,400. And it was meters times meters times meters, which again is, of course, meters cubed.